The sliding filament theory explains how muscles contract at a molecular level. It centers on the interaction between actin, thin filaments, and myosin, thick filaments, within the sarcomere, the basic contractile unit of muscle. 1. The sliding process. Muscle contraction occurs when the thin filaments, actin, slide past the thick filaments, myosin, within the sarcomere. This sliding action is driven by the cyclical binding and unbinding of myosin heads to actin, pulling the thin filaments towards the center of the sarcomere. This process shortens the sarcomere without changing the lengths of the individual filaments themselves. 2. Role of myosin heads. Myosin heads, protruding from the thick filaments, act as molecular motors. They bind to specific sites on actin filaments, forming cross bridges. The binding of ATP to the myosin head initiates a conformational change, causing the head to pivot and pull the actin filament along. ATP hydrolysis provides the energy for this power stroke. Detachment of the myosin head from actin requires the binding of another ATP molecule. 3. Changes in I-band and H-zone. The I-band, which contains only thin filaments, shortens during muscle contraction. The H-zone, located in the center of the sarcomere and containing only thick filaments, also shortens. The A-band, which encompasses the entire length of the thick filament, does not change its length during contraction. These changes in band lengths are direct consequences of the sliding filaments. As actin filaments slide towards the center, the I-band and H-zone narrow because the overlap between actin and myosin increases. 4. Regulation of contraction. The interaction between actin and myosin is regulated by calcium ions Ca2+. When Ca2+ levels rise, they bind to troponin, a protein associated with actin, triggering a conformational change that exposes the myosin binding sites on actin. This allows myosin heads to bind to actin and initiate the sliding process. When calcium levels decrease,